Hello there, and welcome back to our shared corner of the cosmos. I'm so glad you found your way here tonight. Perhaps the world outside has been a little too loud, or perhaps your mind is simply searching for a quiet place to land after a long day. Whatever has brought you here, know that you are exactly where you need to be. There is nothing left for you to do now. No problems to solve, no schedules to keep, and no expectations to meet. This is your time to simply exist, to let your body grow heavy and your thoughts grow light, like stardust drifting on a silent solar wind. As we prepare to embark on tonight's journey through the vast, expanding mysteries of our universe, I invite you to settle into a position of total comfort. Feel the support beneath you, and notice the gentle rhythm of your own breath, the quiet, steady rise and fall that connects you to the heartbeat of the world. If these calm explorations of the stars help you find the rest you deserve, consider subscribing to our journey. It is a small gesture that helps our community grow, ensuring these stories of the infinite reach everyone who needs a moment of peace. Tonight, we aren't just looking at the sky. We are stepping away from the familiar glow of our cities and the frantic pace of our lives to wander through the deep indigo reaches of the great unknown. We will drift past the boundaries of our own solar system, moving gently from one cosmic wonder to the next. We will contemplate the ancient light that has traveled for eons just to reach your eyes, the lonely planets wandering between the stars, and the invisible threads that hold the very fabric of reality together. The universe is a place of profound silence and unimaginable scale, yet it is also our home. Every atom within you was forged in the heart of a dying sun, and every breath you take is an echo of the cosmos. So, let your mind slow down. Let your peripheral thoughts fade into the shadows. We are moving away from the noise and into the clear, cold, and beautiful dark. If you're ready, let us begin our drift into the infinite. Chapter 1. The Ancient Age. The universe is a place of profound scale, and yet everything we see, every shimmering star, every drifting cloud of gas, and every planet tucked away in a distant corner belongs to a single, continuous story that began long before memory. To understand our place in the quiet dark, we must first look back to the very beginning, to a moment when the clock of existence first started to tick. Most astronomers and cosmologists, through decades of careful observation and the study of light that has traveled across unimaginable distances, believe the universe is approximately 13.8 billion years old. It is a number so large that the human mind cannot truly grasp it. We can say the words, we can write the digits, but to feel 13.8 billion years is like trying to count every grain of sand on every shore or every drop of rain that has ever fallen. This estimate is not a guess. It is a conclusion drawn from the echoes of the Big Bang itself. We look at the cosmic microwave background, the faint, lingering heat of creation, and we measure the speed at which galaxies are racing away from one another. By calculating this expansion backward, we arrive at that singular point in the past. But here, in the stillness of the night, we can admit that even our best measurements carry a sense of wonder and uncertainty. In recent times, new observations of ancient stars and distant primitive galaxies have begun to whisper a different story. Some of these celestial bodies appear to be older than the current estimates of the universe allow. They stand as silent anomalies, elder sentinels that challenge our understanding of time. If you were to sit on the edge of a distant galaxy and look out into the void, you might wonder if what we call the beginning was truly the start of everything. There is a quiet tension in the halls of science today, a debate between the math we trust and the stars we see. Some researchers suggest that the rate of expansion has changed in ways we don't yet fully comprehend, perhaps influenced by the mysterious hand of dark energy. Others wonder if the universe is much older, perhaps twice as old as we once thought. This doesn't make our current knowledge wrong. It simply means the story is deeper and stranger than we ever dared to imagine. Imagine, for a moment, that the Big Bang was not the definitive birth of reality, but perhaps just a single chapter in a book with no beginning. It is possible that our universe is just one part of a longer, grander cycle. We live in a sliver of time, a brief window where the stars are bright and the galaxies are close enough to touch with our telescopes. But the ancient age reminds us that we are part of a lineage that stretches back into a darkness we are only just beginning to map. As you lie here, resting, consider the light from those most ancient stars. That light has been traveling through the emptiness for billions of years. It has moved past forming galaxies, survived the death of suns, and crossed through the vast, cold voids, all to land gently in your vision. When you look at the night sky, you are not seeing the world as it is. You are seeing the world as it was. You are a time traveler, witnessing the childhood of the cosmos. There is a peace in this ancient scale. Your worries, your triumphs, and the frantic pace of your day are all held within the palm of this immense history. In the eyes of the universe, 13.8 billion years is a long time, but it is also just the start. We are living in the early days of a cosmos that is still growing, still cooling, and still revealing its secrets. The questions that remain, the gaps in our knowledge, and the stars that seem too old are not frustrations. They are invitations to dream. They remind us that there is always more to discover in the quiet dark. As we contemplate this vast span of time, our thoughts naturally drift from the history of the whole to the smaller, hidden details within it. If the universe is this old and this vast, imagine the sheer number of worlds that have been born and lost in that time. Not all of them stayed within the warm embrace of a sun. Some, in the chaotic dance of gravity, were set free to wander the spaces between the stars. Let us now move away from the timeline of the universe and venture into the silent, starless voids, where the lonely wanderers of the cosmos drift in eternal night. Chapter 2. The Rogue Wanderers. As we leave behind the immense, shifting timelines of the early universe, we begin to descend into the more intimate, yet equally mysterious, pockets of the present-day cosmos. In our everyday experience, we think of planets as loyal companions to stars. We picture our own Earth, held firmly in the warm, golden grip of the sun, or the giant Jupiter, leading its choir of moons in a predictable, circular dance. We have been taught that a world needs a star to exist, to provide light, to offer warmth, and to serve as a gravitational anchor in the vastness of the galaxy. But as we drift deeper into the darkness between the constellations, we discover a silent population that defies this rule. These are the rogue planets, the nomads of the Milky Way. Imagine a world that knows no sunrise. A world where the sky is not a brilliant blue or even a hazy red, but a permanent, deep obsidian, broken only by the distant, unwavering pinpricks of stars that are too far away to offer even a glimmer of heat. These planets do not orbit a sun. They are completely unbound, drifting through the frozen reaches of interstellar space with a quiet, lonely grace. Astronomers estimate that for every star we see in the sky, there may be 1, 2, or even dozens of these rogue worlds. In our galaxy alone, there could be billions, perhaps even trillions of these silent wanderers, outnumbering the very stars that give the Milky Way its name. The story of how a planet becomes a rogue is often one of chaos and cosmic upheaval. Most of these worlds likely began their lives in the crowded, dusty nurseries of young star systems, just as Earth did. They were born from the same swirling disks of gas and ice, growing larger as they swept up debris in their path. But in the early, turbulent years of a solar system's formation, gravity is a fickle master. As giant planets like Jupiter or Saturn migrate and shift, their immense gravitational pull can act like a slingshot. A smaller planet, caught in the wrong place at the wrong time, can be accelerated to incredible speeds and flung out of its home system forever. It is a profound thought. A world, once part of a family, cast out into the infinite cold. Once they leave the light of their parent star, they begin a journey that may last for billions of years. They move through the void between the stars, which we now know is not empty at all, but populated by these dark, freezing spheres. Because they have no star to illuminate them, they are nearly impossible to find. They do not shine with their own light, and they are too small to block the light of distant galaxies in a way that we can easily see. We find them only by chance, through a phenomenon called microlensing, where the gravity of a drifting planet acts like a magnifying glass, briefly warping and brightening the light of a background star as the rogue passes in front of it. It is a fleeting hello from a ghost in the dark. Despite their name, there is a quiet dignity to these wanderers. They are not lost, so much as they are simply following a different path. Without a sun to scorch them or tidal forces to pull at them, they exist in a state of nearly perfect equilibrium with the vacuum. Some of these planets are gas giants, massive and shrouded in thick atmospheres of hydrogen and helium. Others may be rocky. On these rocky rogues, the surface is frozen solid, a wasteland of nitrogen, ice, and silent mountains. Yet, even in this extreme cold, some scientists wonder if life could find a way to endure. Deep beneath the frozen crust of a rogue planet, the core might still be warm, heated by the decay of radioactive elements left over from its birth. If a planet has a thick enough atmosphere to act as a blanket, or a deep enough ocean protected by a miles-thick shell of ice, it could theoretically harbor liquid water. In the pitch-black depths of such an ocean, far from any ray of sunlight, life might survive on geothermal energy, huddled around volcanic vents on the seafloor. It would be a world of total darkness. There is a strange comfort in the existence of these billions of silent worlds. They remind us that the universe is far more populated than it appears to our eyes. The spaces we perceive as empty are actually filled with hidden histories, with mountains that have never seen a shadow and valleys that have never known the wind. As you lie here, safe and warm, try to visualize the slow, majestic drift of a rogue planet. It spins on its axis, just as Earth does, but it does so in a cathedral of silence. It is a world at peace, untouched by the storms of a sun or the radiation of a nearby star. As we contemplate these lonely nomads, drifting through the dark, we begin to see that even the most solid things in the universe are in a state of constant, rhythmic movement. The rogue planet follows the curves of the galaxy, moving in a long, slow arc around the galactic center. This realization that everything, from the smallest planet to the largest galaxy, is part of a grand, repeating motion, leads us to wonder about the nature of time and space itself. If a planet can survive the loss of its star, could the universe itself survive its own ending? The rhythm of the rogue planet's journey is just a small echo of a much larger beat. We have looked at the ancient history of the cosmos, and we have seen the lonely wanderers that inhabit it today. Now, let us turn our minds toward the ultimate rhythm, the possibility that the entire universe is not a one-time event, but a song that repeats forever. Chapter 3. Infinite Cycles. The rhythm of the rogue planet's journey, a slow, persistent arc through the dark, is but a single note in a much larger symphony. When we look at the universe as a whole, we often find ourselves searching for a definitive beginning and a final, silent end. We want to believe in a linear story, one that starts with a spark and concludes with a fading ember. But as we drift deeper into the theoretical reaches of cosmology, we encounter a possibility that is as beautiful as it is profound. The idea that the universe does not follow a straight line, but a circle. A rhythm that repeats, a breath that is taken and released, over and over, across unimaginable spans of eons. This is the concept of the cyclical universe, or the Big Bounce. In our current understanding, the standard model of cosmology tells us that everything began with the Big Bang, a moment of infinite density and heat that expanded into the stars and galaxies we see today. In many versions of this story, the expansion continues forever, with galaxies moving further and further apart until the lights of the universe eventually go out, leaving behind a cold, lonely void. But there is another school of thought, one that suggests the universe is not a one-time event, but a recurring one. Imagine, if you will, the universe as a grand cosmic lung. It expands, reaching outward, cooling and creating structures like the ones we inhabit. But perhaps there is a limit to this expansion. Perhaps, in the far distant future, the energy of that initial spark begins to wane, and the relentless pull of gravity, the collective weight of every atom, every black hole, and every dark matter filament begins to take hold. Slowly, almost imperceptibly at first, the expansion halts. The galaxies stop their outward flight, and then the great contraction begins. In this Big Crunch scenario, the universe begins to fold back in on itself. The vast voids between galaxies begin to shrink. The light from distant stars, which has been stretched into long, cool waves, begins to compress and turn blue, then white, then a searing violet. The universe grows warmer and more crowded. Distant worlds that were once lost to the cosmic horizon return to view as the fabric of space itself is reeled back in. It is a reversal of everything we know. The chaos of expansion is replaced by the focus of collapse. But here is where the cycle becomes truly remarkable. In a linear world, this collapse would simply be the end, a final point of destruction. But in a cyclical model, the universe does not disappear. Instead, as it reaches a point of nearly infinite density, something fundamental happens. The laws of physics, under such extreme pressure, might act like a compressed spring. Instead of vanishing into a singularity, the universe bounces. It reaches a threshold where it can no longer be contained, and it rebounds, triggering a new Big Bang, a new expansion, a new beginning. As you lie there, drifting on the edge of sleep, consider the peace that comes with this idea. It suggests that nothing is ever truly lost. Every star that has ever burned out, every planet that has drifted away into the dark, and every thought that has ever been thought might be part of a grander, repeating pattern. We are not living in the final version of reality. We are simply experiencing one breath in a sequence that may have no beginning and no end. This cyclical nature mirrors everything we see in our own lives and in the world around us. We see it in the changing of the seasons, as the cold of winter eventually gives way to the green of spring. We see it in the tide, which pulls away from the shore only to return with the same steady force. We see it in the stars themselves, which are born from the dust of stars that died long ago. The universe, it seems, is a master of recycling. It takes the old, the broken, and the dark, and it uses it as the foundation for something new and radiant. Some theories suggest that each new cycle might carry subtle imprints of the one that came before. Like a faint echo in a vast hall, the laws of physics might shift slightly from one bounce to the next. In one universe, gravity might be a little stronger. In another, light might travel a little slower, but the rhythm remains. Each cycle is a new opportunity for complexity to flourish, for stars to ignite, and for life to wonder about the dark. There is a deep, structural comfort in this repetition. It removes the burden of the end. If the universe is infinite in its cycles, then time itself becomes a loop rather than a countdown. We are part of a story that is being told over and over, each time with different characters and different stars, but with the same underlying sense of wonder. As we dwell on these immense cycles of expansion and collapse, we realize that the only way we can even know these stories is through the information the universe leaves behind. To understand the rhythm of the whole, we must look at the oldest evidence we have. We must look at the light that was released during the very first clearing of the fog, the moment the universe first became transparent enough for light to travel. The ancient breath of the Big Bang is still out there, humming in the background of everything. To find it, we must travel back to the moment where the glowing fog finally parted, revealing the first clarity of the stars. Chapter 4. The First Clarity. To understand the rhythm of the infinite, we must look at the oldest evidence the universe has ever left behind. As we drift away from the theoretical loops of expansion and collapse, we travel back in time to a moment of profound transformation. Imagine the universe in its infancy, not as the cold, dark void we know today, but as a searing, opaque mist. For the first few 100,000 years, the cosmos was a glowing fog, a thick plasma so hot and dense that light itself was a prisoner. In this era, photons, the tiny particles of light, could not travel far. Every time a photon tried to move through space, it would immediately collide with a free-roaming electron, scattering like a person trying to run through a dense, frantic crowd. There was no such thing as sight or transparency. The entire universe was a brilliant, uniform glow, but it was a glow that held no images, no stars, and no shadows. It was a time of beautiful, chaotic confinement. But as the universe continued its relentless expansion, a quiet change began to take hold. The temperature, which had been millions of degrees, slowly began to drop. Space stretched, and as it stretched, the energy within it began to cool. About 380,000 years after the initial spark, the universe reached a critical threshold, a temperature of roughly 3,000 degrees Kelvin. At this precise moment, a cosmic miracle occurred. The free electrons, which had been darting about and blocking the light, finally slowed down enough to be captured by atomic nuclei. They fell into stable orbits, forming the first neutral atoms of hydrogen and helium. Suddenly, the crowd that had been blocking the photons vanished. The fog cleared. The universe, for the very first time, became transparent. The photons that had been trapped for eons were suddenly set free. They rushed out into the newly cleared space, beginning a journey that would last for billions of years. This moment is known as recombination, but it is more poetically described as the era of the first clarity. It was the moment the universe took its first breath of light. That light is still traveling today. It has been stretched by the expansion of space, cooling from a searing white heat into faint, invisible microwaves. We call this the cosmic microwave background. It is the oldest direct signal we can observe, not from a specific star or a distant galaxy, but from the universe itself, when it was still just a child. It is a quiet, ever-present hum that fills the room around you, a memory of the day the lights first turned on. When we detect this light with our instruments, we see a map of the early universe. It isn't perfectly smooth. There are tiny, subtle ripples, regions that were slightly denser or slightly cooler than others. These ripples are the seeds of everything we see today. Without those small imperfections in the first clarity, gravity would have had nothing to pull together. There would be no clusters of galaxies, no nurseries of stars, and no planets to rest upon. Every mountain, every ocean, and every person began as a tiny fluctuation in that ancient, glowing fog. Consider the journey of these photons. They have been flying through the dark for over 13 billion years. They have passed through the birth of the first stars and the collision of the first galaxies. They have moved silently through the vast empty spaces where nothing exists, and now they are here. They are passing through the walls of your home, through the atmosphere of our planet, and through the very cells of your body. You are immersed in a sea of ancient light, a quiet reminder that you are never truly alone in the dark. You are connected to the very beginning of time. There is a deep peace in this clarity. It tells us that even the thickest fog eventually parts. Even the most chaotic energy eventually finds its way into order. The universe waited hundreds of thousands of years to reveal itself, and in that waiting, it prepared the stage for everything that would follow. As we rest in the glow of this first clarity, we begin to realize that the universe's capacity for order and beauty is limited only by its imagination. When that first light was set free, it revealed a canvas upon which the most extraordinary things could be built. In the vastness of that newly transparent space, chemistry began to experiment with the elements. In some corners of the sky, under the right conditions and the most intense pressures, the universe didn't just create stars and gas, it created treasures beyond our wildest dreams. Beyond the clouds of ancient hydrogen, there are worlds where the very ground beneath your feet is made of the stuff of legends. Let us drift now toward a place where the darkness sparkles with a different kind of light, toward stars that have birthed planets made entirely of crystal. Chapter 5. Crystalline Worlds. The clarity of the early universe did more than just let light travel. It allowed for the first complex dances of chemistry. In the vast, newly transparent stage of the cosmos, gravity began to pull at the cooling gases, spinning them into disks and eventually crushing them into the hearts of stars and the bodies of planets. We often think of planets as being similar to our own rocky surfaces, liquid oceans, or thick, swirling atmospheres of gas. But in the deeper reaches of space, where the ingredients of a solar system differ from ours, the universe experiments with forms of matter that sound more like ancient folklore than modern science. We are drifting now toward a place where the darkness is broken by the inner fire of gems, the diamond planets. In our own solar system, the recipe for planets was heavy on oxygen and silicon, leading to the familiar rocks and sands of Earth and Mars. But space is vast, and its chemical distribution is not uniform. Far from here, orbiting distant stars, there are systems where carbon was the dominant ingredient. In these carbon-rich environments, the birth of a planet takes a different path. When a planet forms with an abundance of carbon under the immense, steady pressure of its own gravity, it doesn't just create coal or graphite. Instead, deep within its interior, the carbon atoms are forced into a rigid, beautiful lattice. They become diamond. There is one such world that astronomers have studied with quiet fascination, a dense, compact planet orbiting a pulsar, the spinning remains of a dead star. This world is a survivor, a remnant of a star that was once much larger. Over eons, its outer layers were stripped away by its pulsar companion, leaving behind only the ultra-dense core. Based on its mass and its size, scientists believe this world is essentially a giant, crystalline form of carbon, a diamond the size of a planet, spinning in the cold, radioactive glow of a dead sun. Try to visualize the surface of such a place. It would not sparkle like a jewel in a shop window. There is no sunlight there to hit its facets. Instead, it would be a world of dark, geometric landscapes, vast plains of obsidian-like crystal, towering ridges of diamond that have never known the touch of rain or the breath of an atmosphere. Under the immense pressure of the planet's gravity, the very ground would be harder than anything we can imagine. If you could stand there, you would be standing on a world that is fundamentally a single, continuous structure, a monument to the power of cosmic pressure. These crystalline worlds remind us that the normal we see in our own neighborhood is just one of a billion possibilities. The universe does not have a single blueprint. It is a master of adaptation, using whatever elements are at hand to build something stable, something lasting. In one corner, it builds a world of water. In another, a world of iron. and in the deep, carbon-rich shadows, it builds a world of crystal. But diamond planets are not the only strange treasures hidden in the dark. There are gas giants where it rains liquid glass, sideways in howling winds, and icy moons where volcanoes spew frozen water instead of fire. There are worlds where the sky is green, and the oceans are made of liquid methane. Each of these places is a quiet testament to the diversity of the first clarity. Once the fog parted, the universe became a laboratory of infinite variety. As you contemplate these glittering, alien landscapes, let your mind rest on the idea of stability. A diamond is a symbol of endurance, a structure that remains unchanged for billions of years. It is a quiet anchor in a universe that is otherwise constantly shifting and expanding. Even in the face of the pulsar's intense radiation, the crystalline planet holds its form, spinning silently, a dark jewel in the velvet void. But as solid as these diamond worlds may seem, they are still just individual points within a much larger, more fluid geometry. Even a planet made of the hardest substance in existence must follow the invisible curves of the space it inhabits. We have looked at the ancient age, the lonely wanderers, and the crystalline treasures. But now we must ask, what is the shape of the room they all live in? If we were to fly past the furthest diamond planet, would we eventually find a wall or an edge? Or is the universe a different kind of structure, one that folds back on itself, leading us in an eternal, curved loop? Let us drift away from the sparkling surfaces of these rare worlds and consider the very shape of space itself, a journey that leads not to an end, but back to the beginning. Chapter 6. The Endless Loop. As we leave behind the solid, sparkling surfaces of the diamond worlds, we find ourselves drifting out into a different kind of vastness. We have looked at the things that inhabit the universe, the ancient stars, the lonely planets, the crystalline treasures, but now we must turn our gaze toward the very room in which they live. We must ask ourselves about the container of all reality. Where does it end? If you were to point a ship toward the deepest, darkest patch of the night sky and fly with unimaginable speed for 1 trillion years, what would you find? A wall? A border? Or perhaps something much more mysterious? It is a natural human instinct to look for an edge. We are used to a world with boundaries, shores that meet the sea, fences that mark a garden, the horizon that separates the earth from the sky. But space, it seems, does not abide by our terrestrial rules. According to the profound insights of general relativity, the shape of the universe is not a flat, infinite tabletop. Instead, the shape of space is determined by what is inside it. Every star, every galaxy, and every hidden pocket of dark matter acts like a weight on a soft fabric, stretching and curving the geometry of the nothingness around it. When we consider the universe as a whole, the evidence suggests something that is almost impossible to visualize, yet deeply peaceful to contemplate. The universe may be finite in volume, yet it has no edge. It is a loop. This is the concept of a closed universe, a space so vast and so perfectly curved that it wraps around itself in every direction. Imagine a tiny ant crawling on the surface of a giant, perfectly smooth balloon. To the ant, the world seems endless. It can walk in any direction for as long as it desires, and it will never fall off a cliff. It will never hit a brick wall that says, "End of the world." The surface of the balloon has no beginning and no edge. And yet, the ant's world is not infinite. It is a contained, measurable surface. If the ant were to walk in a perfectly straight line, never turning, never wavering, it would eventually, after a very long journey, find itself back at the exact spot where it began. Not because it turned around, but because the very ground it walked upon was curved into a circle. The universe may work in exactly this way, but on a scale that defies our everyday senses. If you traveled far enough through the cosmos, you wouldn't reach a boundary. Instead, you would simply wrap around the curvature of space-time. You could, in theory, look through the most powerful telescope imaginable and, if you looked far enough, see the back of your own head. The light of our own Milky Way, having traveled through the great loop of the cosmos, would return to us from the opposite side of the sky, faint and ancient, having completed the ultimate journey. There is a profound stillness in this idea. It suggests that the universe is a complete and self-contained thought. It is not an attic filled with dust that goes on forever into a messy infinity. It is a masterpiece of geometry. Everything is connected. Every distant galaxy you see is part of the same here. In a looped universe, there is no outside. There is only the internal, beautiful, and eternal inside. This curvature also means that the universe is never truly empty. Even when we look at the great voids between galaxies, we are looking at the curved fabric of reality itself. This fabric is what allows light to travel, what allows gravity to pull, and what allows time to flow. As you lie here, feel the sense of being held within this great cosmic loop. You are not adrift in an endless, terrifying void that leads to nothingness. You are resting within a structure that is whole, finished, and perfectly balanced. In this endless loop, the concept of far away becomes a matter of perspective. A galaxy may be billions of light years away, but it is still sharing the same curve of space as the atoms in your own body. We are all passengers on a vast, geometric carousel, moving through a space that always leads back to the center of our own wonder. But as we contemplate the grand, invisible curves that shape the path of every star, we begin to realize that our own sun, the steady, golden heart of our world, has its own hidden history within this geometry. We see it every day, alone in our sky, providing the light that allows us to dream. But was it always this way? Just as galaxies interact and space loops back on itself, the stars themselves are rarely born in isolation. Deep in the archives of cosmic history, there are clues that our sun once had a companion, a lost twin that shared its birth before drifting away into the silent, curved corridors of the galaxy. Chapter 7. The Sun's Lost Sibling. As we drift away from the grand, geometric loops of the infinite universe, we return to a place that feels a bit more like home. We return to our own neighborhood, to the familiar golden glow of the Sunday. For as long as humanity has looked upward, we have seen our star as a solitary figure, a lone guardian standing watch over the planets, steady and singular in the vast, velvet sky. We take comfort in its isolation, in the predictable way it rises and sets, providing a constant anchor for our lives. But as we peer back through the long, dusty corridors of time, we find a hidden chapter in our sun's biography, a story of a shared beginning and a silent parting. In the modern cosmos, we observe that stars are rarely born alone. When we look into the great stellar nurseries, the massive clouds of gas and dust like the Orion Nebula, we see that stars emerge in clusters, like siblings sharing a cradle. In fact, more than half of the stars in our galaxy are part of binary or multiple systems, locked in a gravitational embrace with one or more companions, orbiting each other in a dance that lasts for billions of years. It would be a statistical anomaly for our sun to have been born in total isolation. Recent astronomical research and sophisticated computer modeling suggest that over 4.5 billion years ago, our sun was likely born with a twin, a lost sibling, formed from the same collapsing pocket of gas, sharing the same chemical DNA. For a brief period in the dawn of our solar system, there may have been two lights in our sky, two suns, casting shadows across the nascent, molten surfaces of the early planets. This hypothetical twin, often nicknamed Nemesis by those who search for it, would have been a companion in every sense of the word. But the galaxy is a restless place, As the suns matured and moved away from their birth cluster, the gentle but relentless gravitational tugs of passing stars and the immense tidal forces of the Milky Way itself began to pull at the bond between them. In the slow-motion choreography of the galaxy, the two stars began to drift apart. Like two ships departing from the same harbor, they set out on slightly different headings, until the distance between them became too vast for gravity to hold. Eventually, the connection snapped. Our sun's lost sibling drifted out into the wider galaxy, becoming a wanderer among billions of other stars. Today, it is out there somewhere, perhaps on the other side of the Milky Way, perhaps just a few hundred light-years away, masquerading as just another anonymous point of light in a distant constellation. It carries the same signature of heavy elements, the same age, and the same history as our own sun. But it has lived a completely different life. It may host its own family of planets, its own silent, rocky worlds, or its own diamond-hearted cores, all orbiting a star that looks exactly like the one that warms our skin. There is a bittersweet peace in this thought. Even our sun, which seems so solitary, has a connection to the wider cosmic family. It reminds us that everything we see, even the most stable and isolated objects, has a history of connection, of shared origin, and eventually, of letting go. The sun's lost twin is a ghost of our past, a reminder that we are part of a larger, interconnected web of stellar evolution. But why does this matter to us now, as we drift towards sleep? Because it teaches us about the nature of gravity, the invisible thread that binds all things together. Gravity is what brought the twins together, and gravity is what eventually allowed them to part. It is the same force that keeps your body grounded to the earth and the moon anchored to our sky. It is a force that can be gentle, like the drift of a twin star, or it can be unimaginably intense, compressing matter until the very laws of reality begin to warp. As we contemplate the sun's lost partner, we begin to wonder about the extremes of this gravitational dance. What happens when a star doesn't just drift away, but collapses inward? What happens when the weight of a sun is crushed into a space no larger than a city? Let us leave the golden warmth of our neighborhood and travel toward the remnants of stars that have reached the ultimate limit of density. We are moving away from the light of twins and toward the heavy, silent ghosts of the stellar graveyard. Chapter 8. Crushed Gravity. The gentle parting of sibling stars reminds us that gravity is the great weaver of the cosmic tapestry, a force that can hold worlds in a tender embrace or slowly let them go. But as we move deeper into the heart of the stellar graveyard, we find places where gravity is no longer gentle. We find places where it has become a master of absolute compression, a force so relentless that it defies the very nature of matter. We are drifting now toward the remnants of the most massive stars, the neutron stars, where reality is crushed into a state of impossible density. When a star much larger than our sun reaches the end of its life, it does not simply fade away like a cooling ember. Instead, it concludes its journey with a spectacular explosion, a supernova that briefly outshines an entire galaxy, but the explosion is only half the story. While the outer layers of the star are blasted into the void to seed the universe with new elements, the core of the star experiences a different fate. In a matter of seconds, the weight of an entire sun is crushed inward by gravity. The pressure becomes so intense that even atoms, the fundamental building blocks of everything we know, can no longer hold their shape. In a terrifyingly beautiful display of physics, the electrons and protons of the star's core are squeezed together until they merge, turning into a solid ball of neutrons. What remains is a neutron star, a sphere only about 20 kilometers wide, roughly the size of a small city, yet containing more mass than our entire Sunday. It is a ghost of a star, small, dark, and spinning with a fury that defies imagination. To understand the weight of such a place, we must look at it through the lens of our own world. Imagine a single raindrop falling gently from a summer cloud. On Earth, that raindrop is light, almost weightless as it lands on your skin. But if you were to take a single raindrop of neutron star material, it would not be light at all. Because of the extreme compression, that tiny drop would weigh more than Mount Everest. A single teaspoon of this neutron soup would weigh billions of tons. It is matter in its most extreme form, atoms crushed so tightly that there is no space left between them. It is nearly pure gravity, held in a palm-sized sphere. Life on such a world is an impossibility. The gravitational pull on the surface of a neutron star is 200 billion times stronger than that of Earth. If you were to drop a pebble from just a few feet above its surface, it would hit the ground at millions of miles per hour, releasing more energy than a nuclear bomb. The surface itself is unimaginably smooth, with mountains only a few millimeters high, because gravity refuses to let anything stand tall. Yet, even in this extreme environment, there is a strange, frozen kind of peace. Deep inside the neutron star, the matter may exist as a superfluid, a liquid that flows without friction, a silent, swirling ocean of neutrons that never slows down. And many of these stars are pulsars, spinning hundreds of times every second, beaming light out into the dark like a cosmic lighthouse. They are the universe's most precise clocks, ticking away in the silence of the graveyard, marking time with a rhythm that will last for billions of years. As you lie here, safe in the soft, low gravity of Earth, let the sheer weight of a neutron star anchor your thoughts. Feel the stability of a universe that can hold such incredible density without breaking. The neutron star is a final state, a place where matter has reached its limit and found a new, stable form. It is a survivor of stellar violence, now resting in the dark, heavy, and silent. But as powerful as this crushed gravity is, it does not always act alone. Sometimes, the gravity of these massive objects does more than just crush matter. It bends the very path of light. In the same way that a neutron star is a ghost of what once was, the light we see in the sky can sometimes be a ghost, a mirage created by the warping of space itself. As we move away from the heavy, spinning hearts of neutron stars, we begin to see how gravity can act as a lens, distorting our vision of the cosmos and showing us the same galaxy in multiple places at once. We are moving from the weight of matter to the bending of sight. Chapter 9. The Mirages of Space. As we leave behind the heavy, silent ghosts of the stellar graveyard, we find that gravity has one more trick to play on our senses. We have seen gravity as a builder of stars and a crusher of matter, but now we observe it as a master of illusion, a cosmic lens that warps the very light we use to see. In the vast reaches of the deep universe, space is not a clear, empty window. It is a fluid, bending fabric, and sometimes what we see in the distance is not a single object, but a beautiful, shimmering mirage. For most of human history, we believed that light always traveled in perfectly straight lines. We imagined photons as tiny arrows darting through the void, moving directly from a star to our eyes. But Albert Einstein's vision of the universe changed everything. He realized that if space and time are a fabric, then a massive object, like a cluster of 1,000 galaxies, must create a deep well in that fabric. When light from an even more distant source passes near that well, it cannot stay on a straight path. It is forced to follow the curve. It bends, just as a beam of light bends when it passes through a piece of glass or the surface of a still pond. This is what astronomers call gravitational lensing. It is one of the most hauntingly beautiful phenomena in all of physics. Because the light is bent around the massive foreground object, it can take multiple paths to reach us. Imagine a distant, glowing galaxy sitting directly behind a massive cluster. Some of its light travels above the cluster, while some travels below or to the sides. When these separate paths of light finally reach our telescopes, they don't show one galaxy. They show 2 or 4 or even a complete circle of light known as an Einstein ring. Think of the piece in that image, a perfect ring of golden light, glowing in the deepest black of the void. It is a cosmic hall of mirrors, where the universe shows us duplicates of the same distant world. These aren't separate galaxies, they are echoes in vision, different routes that light has taken through the warped corridors of space-time to find its way home to us. In rare and extraordinary cases, we have even seen a supernova, the death of a single star, explode 4 different times in the sky, as its light arrived at different intervals through different gravitational routes. It is as if the universe is giving us a chance to watch its most spectacular moments on a slow-motion replay. But these mirages are more than just beautiful illusions. They are a magnifying glass provided by the universe itself. Gravitational lensing allows us to see galaxies that are far too distant and far too faint for even our most powerful telescopes to detect on their own. The gravity of the lens amplifies the light, pulling it from the shadows and stretching it into view. It is a quiet reminder that in the cosmos, even the most formidable obstacles like the crushing weight of a galaxy cluster can become a bridge to deeper understanding. As you lie here, resting, consider the journey of that light. It has been bent and shaped by the invisible hand of gravity. It has traveled through regions of space where the very geometry is warped, yet it never stops. It finds its way through the curves and the mirages, crossing billions of light years to share its story. There is a profound sense of direction in this. Even when the path is not straight, the light arrives. Even when space is warped, the information persists. This bending of light reveals the hidden structure of the universe. It shows us where the invisible mass lies, pointing toward the dark matter that we cannot see but can only feel through its pull. It reminds us that what we perceive with our eyes is only a small fraction of the truth. Beneath the mirages and the glowing arcs of light, there is a scaffolding, a hidden architecture that has existed since the very beginning. But before the universe had these massive clusters to act as lenses, it was a much simpler place. Before the first mirages could form, the first light-bearers had to ignite. These were the pioneers of the dark, the ancient stars that were unlike anything we see today. They were born into a world of pure hydrogen, burning with a fierce, lonely brilliance that cleared the way for everything that followed. As we drift away from the warped light and the cosmic mirrors, let us travel back to the era of the first fires, to the stars that were born 1,000,000 times brighter than our own, seeding the darkness with the very elements that would one day become you. Chapter 10. The First Light-Bearers. The mirages we see today, those shimmering arcs and rings of light, are only possible because the universe has spent billions of years building vast structures, massive clusters of galaxies that act as cosmic lenses. But to understand how those structures came to be, we must travel back to a much simpler, darker time. We must leave behind the Hall of Mirrors and return to the era shortly after the first clarity, when the universe was transparent but still utterly black. There were no galaxies yet, no planets, no light. Only vast, cold clouds of hydrogen and helium drifting in the silent void. This was the cosmic dark ages. But within that darkness, a change was brewing. Gravity, the patient sculptor, was at work. In the densest regions of these gas clouds, atoms were being drawn together, pulled into tighter and tighter knots. As these knots grew more massive, they began to heat up. The pressure at their centers became so intense that the very first stars began to ignite. These were the population 3 stars, the pioneers of the light. They were unlike any star we see in our modern sky. Born from the pure, pristine gas left over from the Big Bang, they were massive, hot, and incredibly short-lived. Imagine a star 100 times the mass of our sun, glowing with a fierce, violet-blue brilliance. These first light-bearers burned 1,000,000 times brighter than our own star, their radiation tearing through the surrounding gas clouds and ending the dark ages forever. They were the giants upon whose shoulders the rest of the universe was built. Because they were so massive, they burned through their nuclear fuel at a frantic pace. While our sun will live for 10 billion years, these first stars lived for only a few million, a mere heartbeat in the timeline of the cosmos. But their brief lives changed everything. Inside their searing cores, through the process of nuclear fusion, they began to create the very first heavy elements. Before these stars, the universe contained only hydrogen, helium, and a trace of lithium. It was these first light-bearers that forged the oxygen we breathe, the carbon in our cells, and the iron in our blood. When they eventually died, they did so in spectacular explosions called hypernovae, scattering these new elements into the void. Without these ancient, short-lived giants, the universe would have remained a cold, chemical desert. There would be no rocky planets, no complex chemistry, and no life to wonder at the stars. Every atom of substance in your body was once part of that first generation of light. Their brilliance is gone now, their fires extinguished eons ago, but their fingerprints remain in the chemistry of every ancient gas cloud and in the very structure of the galaxies that followed. They were the silent architects of the material world. As you lie here, feel the connection to these ancient pioneers. You are made of their dust. Their brief, intense lives provided the seeds for the long, slow evolution of the cosmos. They turned a dark, empty room into a home filled with the potential for life. There is a profound sense of legacy in this, the idea that even something that exists for only a moment can change the course of eternity. But as we think about the visible light of these first stars, we must also acknowledge the invisible forces that allowed them to form in the first place. The stars provided the light, but something else provided the scaffolding. Even as the first fires ignited, an invisible ocean was flowing around them, holding the galaxies together and guiding the stars in their dance. As you drift closer to the edge of sleep, let your mind move from the bright, burning hearts of the first stars to the ghostly presence that surrounds us even now. We are moving from the light we can see to the matter we can only feel, the silent current that streams through the dark. Chapter 11. The Silent Current. The bright, violent birth and death of the first stars gave the universe its substance. But even as those ancient fires lit the dark, they were being cradled by something much larger and far more mysterious. We have spent our journey looking at the visible world, the glowing gas, the sparkling crystals, and the burning suns. But as we drift into the final chapters of our exploration, we must acknowledge the ghost that haunts the machine. We are entering the realm of the silent current, the enigma of dark matter. As you lie there, perfectly still, it is difficult to imagine that you are currently being washed over by a celestial tide. Yet, according to our most advanced understanding of the cosmos, trillions of invisible particles are streaming through your room, through your blankets, and through your very body, every single second. This is not a mist or a wind that you can feel on your skin. It is dark matter, a form of substance that does not interact with light. It does not reflect the glow of the moon. It does not absorb the warmth of the sun, and it does not emit any radiance of its own. To our eyes and our most sensitive cameras, it is essentially nothing. And yet, it is the most important nothing in the universe. We know it is there because of its gravity. When astronomers look at the way galaxies spin, they see something that shouldn't be possible. The stars at the outer edges of a galaxy, like the Milky Way, are moving much too fast, so fast that they should be flung out into deep space, like water droplets flying off a spinning wheel. The visible matter, the stars and the gas, simply doesn't provide enough gravitational glue to hold them in place. There must be something else there, an invisible anchor, weighing down the galaxy and keeping the stars in their graceful, circular orbits. This invisible anchor is dark matter. It surrounds our galaxy in a vast, spherical halo, extending far beyond the furthest stars. It is the scaffolding upon which the visible universe is built. Without this silent current, the first stars we spoke of would never have been able to huddle together to form galaxies. The universe would have remained a thin, uniform soup of gas, unable to clump, unable to build, and unable to create the complexity that eventually led to us. There is a profound humility in this realization. We, and everything we have ever seen, are just the foam on the surface of a much deeper, darker ocean. About 85% of the matter in the universe is dark. We are the exception. The silent current is the rule. It is an ever-present, ghost-like companion that has been with the universe since its very first moments, quietly guiding the flow of history without ever demanding to be seen. Imagine the peace of this invisible ocean. It is a force that provides stability without noise. It holds the great spirals of the stars together with a gentle, relentless grip, ensuring that the cosmic dance continues across billions of years. As you drift closer to sleep, try to visualize this dark matter not as something frightening, but as a cosmic blanket, a silent, weightless structure that supports the world you know. It is passing through you right now, a reminder that we are part of a reality that is far more interconnected and far more mysterious than our senses can perceive. This silent current doesn't just hold individual galaxies together, it connects them across the unimaginable voids of deep space. It forms a bridge between the islands of light, creating a grand, unified architecture that spans the entire cosmos. As we look at how this dark matter arranges itself, we find that the universe isn't just a collection of random points. It is a network, a web, a structure so organized that it begins to look like something familiar, something deeply personal. Let us drift away from the individual particles passing through your body and look at the grandest map of all. We are moving from the invisible current to the great cosmic web, where the architecture of the universe begins to mirror the architecture of our own minds. Chapter 12. The Living Network. The invisible tide of dark matter that flows through your room and the silent currents that hold our galaxy together are not isolated phenomena. As we zoom out further than we have ever gone before, past the stars, past the diamond worlds, and even past the local clusters of galaxies, we begin to see the grandest design of all. We find that the universe is not a scattered collection of objects drifting in a void. Instead, it is a vast, interconnected masterpiece of architecture. This is the living network, or what astronomers call the cosmic web. When we map the positions of billions of galaxies across the span of the observable universe, a stunning pattern emerges. The galaxies are not distributed randomly like grains of sand tossed on a floor. Instead, they are arranged along delicate, glowing filaments of matter that stretch across hundreds of millions of light years. These filaments act as cosmic highways, drawing gas and stars into dense nodes where thousands of galaxies huddle together in massive clusters. Between these filaments lie the great voids, enormous, nearly empty bubbles of space where almost nothing exists. As you lie there, drifting in the quiet of your own space, try to visualize this structure. It is a web that spans the entire horizon of reality. What is truly unsettling and beautiful about this network is its appearance. When scientists create computer simulations of how dark matter and gravity shape the universe, the resulting image looks uncannily like a neural network, the kind found inside the human brain. The dense nodes of galaxies look like neurons, and the long, thin filaments of dark matter look like the axons and dendrites that connect them. image comparing the cosmic web to a human brain neural network. It is a poetic coincidence of physics, the largest structure we know of in the cosmos and the most complex structure we know of in biology. The human mind share a similar geometric language. Of course, the universe is not thinking in the way we do. It is shaped by the cold, impartial laws of gravity and expansion. Yet, there is a profound peace in knowing that the architecture of the infinite mirrors the architecture of the very thoughts you are having right now. You are a small reflection of a much grander design. This cosmic web is the ultimate stabilizer. It ensures that no galaxy is truly an island. Even in the deepest reaches of the dark, every point of light is connected by invisible threads to the rest of creation. It is a living, breathing system of exchange, where gas flows along the filaments to feed the birth of new stars, and the energy of dying suns ripples outward to touch distant neighbors. As we contemplate this living network, we realize that the universe is a finished, cohesive whole. From the first clarity of ancient light to the heavy hearts of neutron stars, and from the lonely rogue planets to the great filaments of the web, everything is in its right place. The complexity of the cosmos is not a source of chaos, but a source of order. It is a machine designed for endurance, a structure built to last for trillions of years. The network is silent, vast, and steady. It does not rush. It simply exists, holding the stars in their places and providing a home for the mysteries we have explored tonight. As you feel the weight of this interconnectedness, let your mind settle. The journey through the facts of the universe has brought us back to a simple truth. We are part of a system that is far too large to fail and far too beautiful to be accidental. The filaments of the web are the final layer of our journey. They are the boundaries of our vision. As we rest here, at the edge of the great network, the light of the stars begins to dim, and the hum of the cosmos grows softer. We have traveled through time and space, through the seen and the unseen, and now it is time to return to the simplest state of all. We move now from the grand architecture of the living network toward the final, gentle release of the journey where the facts fade away and only the quiet, dark peace of the void remains. The final drift. As we reach the end of this journey through the living network of our universe, the light of distant galaxies begins to soften, and the grand architecture of the cosmic web fades into a gentle, velvet gray. We have traveled across 13.8 billion years of history, witnessed the lonely paths of rogue planets, and felt the invisible pull of dark matter streaming through the silence. Now, the time for discovery is over, and the time for rest has arrived. The immense scale of the cosmos, which once felt so vast, now feels like a quiet, protective blanket. You are not a small, lost point in a cold void. You are a vital part of a grand, interconnected masterpiece. The same physics that guides the spiral of a galaxy is the same physics that guides the rhythm of your breath. The iron in your blood was forged in the hearts of the stars we visited. And the carbon in your cells is an echo of the first light-bearers who cleared the dark. You are, in every sense, the universe experiencing itself in a moment of total peace. Allow the thoughts of diamond planets and neutron stars to dissolve like mist. They are stories of the infinite, and like all stories, they are now being tucked away. Your mind has followed the filaments of the cosmic web back to the center of your own being. Feel the weight of your body as gravity, the same force that holds the sun in its place, anchors you safely to your bed. You are grounded. You are secure. You are exactly where you belong in the vast dance of the stars. The hum of the universe is still there, beneath the silence, but it has become a slow, rhythmic lullaby. It is the sound of space expanding, the sound of ancient light cooling, and the sound of nothingness shifting into a dream. There are no more questions to answer, no more mysteries to solve. The universe is at rest, and so are you. As the final glow of the cosmic microwave background dims in your mind's eye, let go of the last threads of wakefulness. The darkness here is not empty. It is a clear, bright clarity that leads to deep, restorative sleep. Drift now into the soft obsidian night, moving beyond the words, beyond the facts, and into the silent heart of the infinite. Sleep now, as the stars watch over you. Sleep now, as the galaxy turns in its slow, eternal circle. You are home. You are safe. You are part of the light. Good night, traveler.